These are the notes for section 3.5, angles of triangles. The objectives are I will be able to apply the angle sum theorem, and I will be able to apply the exterior angle theorem. First off, let's talk about the angle sum theorem. This is one of the more important things that you'll learn in geometry. The sum of the measures of the angles of a triangle is always 180 degrees. We've already seen 180 is an important number because we have so many angles that are supplementary, while triangles, all three angles, the interior ones, will add up to 180 degrees. So for our examples, we're asked to find the measure of the missing angle or angles. So right here for number 1, I have angle 1 plus 62 plus 90 is equal to 180. So remember, all three angles add up to 180 degrees. So whenever I do this, I just combine like terms, and I can use my calculator to help me out. So 62 plus 90 is 152. So I have angle 1 plus 152 equals 180. And when I subtract 152, I will get angle 1 equals 28 degrees. So I want you to try number 2 on your own. Number 3, we'll start it on top of it. So I have this triangle in blue, triangle MPQ. So I have angle 1 plus 66 plus 58 equals 180. So again, I just do the same thing with my calculator. 66 plus 58. I get that number, and I know I'm going to need to subtract that number. So angle 1 will equal 56. I know that angle 2 has to also equal 56. We've talked about vertical angles from the beginning of the year, and we should know by now that vertical angles are congruent. So vertical angles are congruent, so angle 2 is 56 degrees. And the last angle I'm going to need to find is what's going to be on this red triangle, triangle QON. I'm going to have 56 plus 50, because remember, I got the 56 from angle 2, plus angle 3 is going to equal 180. So again, with our calculators, it's very easy. 56 plus 50 is, let me try that again, 106. I just take 180 and subtract it from 106, and I get angle 3 to be 74 degrees. So try number 2. Remember, we have the angle mark, so angle R needs to be 30 degrees, and that should be all the information you need to do to finish number 2. Moving on, we have something called the third angle theorem. The third angle theorem says if two angles of one triangle are congruent to two angles of another triangle, then blank. But what it says is the third angle, so I'm going to abbreviate it here, the third angles of the triangles are congruent. This is because all three angles need to add up to 180 degrees. So what it says is if I have this triangle ABC here and triangle FED, and I know that angle A is congruent to angle F and angle C is congruent to angle D, well, that just means that the third angles have to also be congruent. So angle B is congruent to angle E. Pretty simple. Another thing that's kind of important is the exterior angle of a triangle. The exterior angle of a triangle is formed by one side of a triangle and the opposite ray of another side. So maybe you remember we talked about opposite rays. So if this is my triangle right here, if I take this point here, the side going off to the right is part of the triangle. The side going off to the left is not part of the triangle. So that's going to be part of the angle. So the angle, the exterior angle, is made up of that part and one side of the triangle, which is right there. So this right here is an exterior angle. Sometimes this will get confusing because you'll see angles on the outside of the triangle that don't form a linear pair or a straight line with one angle of the triangle. We also have something called remote interior angles. Remote interior angles are the interior angles of the triangle, not adjacent. So you should remember this word, adjacent, meant next to a given exterior angle are called remote interior angles of the exterior angle. So if I look at this picture here, I would say angle 1 is an exterior angle and angle 3 and angle 4 are remote interior angles to angle 1. So remember what this word remote means. Remote means far away. That's how we got the name for a remote control on a television. You were able to control what channels you wanted from a TV from a remote or far away location. Before that, you had to go up to the TV and turn a dial or a knob. So the remote made it easy because you were far away. So that's how you can remember remote interior angles. Remote means far away. Another thing is the exterior angle theorem. The exterior angle theorem uses that picture we have above there. It says the measure of an exterior angle of a triangle is equal to the sum of the measures of its two remote interior angles. So what this means is that the measure of angle 1, so that's this angle right here that I'm tracing, is equal to the measure of angle 3 plus the measure of angle 4. So these were the remote interior angles. There are 3 exterior angles on every triangle. This will work for all of them whenever you figure out the remote interior angles. So sometimes we'll be given problems like this where you need to figure out what the remote, or sorry, you'll have to use the theorem we just learned, the exterior angle theorem, to solve for them. So for example, angle 1 is an exterior angle. Its remote interior angles are 50 and 78. So whenever I use that theorem I just learned, I'll say the measure of angle 1 is equal to 50 plus 78, which is just 128 degrees. So the measure of angle 1 is equal to 128 degrees. Knowing that, I can solve all these other angles. So if this is 128, I have angle 2 also, so I'm not using remote interior angles here. I'm using the fact that angle 1 and angle 2 are a linear pair. We've talked a lot about that all year. So, since they're a linear pair, that means they have to equal 180. 128 degrees plus the measure of angle 2 equals 180 degrees. All I have to do is subtract 128, and I get the measure of angle 2 is equal to 52 degrees. So I'm running out of space with this problem. It's a lot easier on your paper because you can write smaller than I can. We'd have to find angle 3 next. So I just figured out that angle 2 is 52 degrees. So I can see I can use my remote interior angle theorem again. So I'm going to have angle 2 plus angle 3 is equal to 120. If I erase it, it'll probably make more sense there. The remote interior angles, when I add them, equal 120. So I just figured out angle 2 was 52 plus the measure of angle 3 is equal to 120. When I subtract 52, I get the measure of angle 3 is equal to 68 degrees. You should be able to finish solving this. Angle 4 is a linear pair, and angle 5 is another exterior angle theorem problem. So find, do this in black, find the measure of angle 4 and the measure of angle 5 on your own, and do problem 5. So you should be able to figure this out. 5 might look a little tricky, but whenever you break it down and see what to do, so to find angle 1, I would have to use the exterior angle theorem. 32 plus 38 is equal to angle 1. So don't get overwhelmed by it. We have a couple of corollaries. This is a word that we haven't used this year to my recollection. But a corollary is just a theorem. Remember, a theorem is something that can be proven, that can be easily proved using another theorem. That's what a corollary is. A corollary is a theorem that can be easily proved using another theorem. So the first corollary we have is the acute angles of a right triangle are complementary. So remember, complementary meant they equal 90 degrees, so they add to 90 degrees. That's because each triangle adds to 180. Well, a right angle, you should remember, is 90 degrees. So that would mean the other two angles would have to add up to 90. 90 plus 90 is 180. That's why this is true. The second corollary says there can be at most one obtuse or right angle in a triangle. This works out because assume that it's false. That would mean I could have two obtuse angles. So let's say I'd have 91 plus 91. I'm already over it, right? That's 182, which is greater than 180. That's why those two things are, why you can't have more than one obtuse or more than one right angle. So we're going to go over a couple more examples. Let's read the directions on what we're supposed to do. It says the variable expressions represent the angle measures of a triangle. Find the measure of each angle, then classify the triangle by its angles. This means the classify part, it's either going to be acute, right, or obtuse. Remember, obtuse is where we have an angle that's greater than 90. Right is where we have an angle that's equal to 90, and acute is where we have three angles less than 90 degrees. So for number 6, we have this triangle RST, and we're told that R and T are x and S is 7x. So what do all three angles add up to? 180 degrees. X plus 7x equals 180. I combine like terms. 1 plus 1 plus 7 is 9x equals 180. When I divide by 9, I get x is equal to 20. So remember, I need to find the measure of each angle. So I substitute. Angle R is going to be 20, and angle T is going to be 20. Angle S is going to be equal to 7 times 20, which is just 140 degrees. So I check, do I have an obtuse angle? Yes. Angle S is an obtuse angle. So when I classify the triangle, it has to be obtuse, because I have an angle bigger than 90 degrees. So it's an obtuse triangle. Number 8 is the last one we're going to do on these notes. I want you to try 7 on your own. For number 8, we need to use our exterior angles theorem. That says x plus 31 is going to equal 2x minus 8. Whenever I solve this, I get my x's on one side first. So x minus 8 is equal to 31. And then I add 8. X will equal 39. So that means the angles that I have are going to be 39 here. And 2x minus 8 is 2 times 39 minus 8. Let's use a calculator to make sure we're doing this right. 2 times 39 minus 8, 70. So 70 is outside of the triangle. That means the angle inside of the triangle has to be 180 minus 70, which is 110. So my three angles in the triangle are 39, 110, and 31. Since 110 is greater than 90, that means this too is an obtuse triangle. So what I'd like you to do is try number 7 on your own. If you have any questions, make sure to ask me, and I hope this was helpful.